guys, welcome back to Wong Chemistry channel. For this video, we are going to discuss about your topic 5.4 phase diagram. It will be a slightly longer video because there will be quite a few things that we need to discuss. We are going to talk about your phase and your component, what is the difference of phases and components, the phase diagram of your water and also your carbon dioxide, the triple point, what is actually triple point, what is actually critical point, and last but not least, we are going to talk about the changes in the phases by using your phase diagram. Okay, we are going to talk about your isobaric and also isothermal. What is the isobaric and isothermal? You need to stay until the end of this video. Alright, let's start straight away with phase and component. So what is actually phase and component? Quite simple. Phase is actually a homogeneous part of a system and is separated from the other parts by a distinct boundary. If you can see there is a boundary, alright, then you are having different phases. So phase is when you can see a distinct boundary in a system, okay? Component is the chemical species of a phase that exists independently. So component is every single compound that you have in your entire system. So how many components you have in that system? Okay, don't worry, there's a very simple example over here. So if you look at it, that is my oil and this is my water. And if you look at it very carefully, we know that your oil and water does not mix. Therefore, you can see a very visible boundary. So, if you see a very visible boundary, how many phases that you have? You are having two phases. One is your oil, another one is your water, because they are not mixing together. And you can see the distinct boundary over here. That is your distinct boundary. Okay? We can see that your oil and your water is separated by a layer. That is how we determine phase. Alright? And how many components that we have? How many compounds that you have in that? How many chemical species that you have in that? You have oil and water. And obviously, your oil and water is a different chemical species. Therefore, we have two components. Okay? That is the first example of your phase and component. Looking at this is our mixture of gas. When you have a mixture of gas, we are having your oxygen and your nitrogen gas in the same beaker. So how many phases that you have? There is only one phase. Why there is only one? Because both of them are gas. And when both of them are gas, look at it. Both of them are gas that are already mixed up into each other. Can you see there is no distinct boundary between your nitrogen and oxygen gas? All the gases is now mixed up, okay? We cannot differentiate. If I have a beaker and I say that I have oxygen gas and nitrogen gas in the beaker, we cannot see which one is your oxygen gas and which one is your nitrogen gas. That's why you only have one phase. But the question is, how many components do you have? You have your oxygen gas and also your nitrogen gas. There is two chemical species. Therefore, you have two components. One is your oxygen gas, another is your nitrogen gas. Alright? Simple. Next, you have your ice over here, which is a solid, and you have your water over here, which is a liquid. Alright? The melting of the ice will give rise to your water. Can you see your water over here? And your ice. So, how many phases that we have? We have two phases. Quite obvious is your ice is a solid, while your water is a liquid. So you can differentiate quite obvious the presence of your solid over here and the presence of your liquid over here. So we have two phases, okay? But all of them is coming from the same component because all of them is your H2O. So how many components we are having? We are having only one component. Just that the one component, the same chemical species, are now exist in two different phases. Your water is in ice, which is a solid. Your water is in liquid form. Although we have a solid and liquid, but both of them coming from the same chemical species. That's why your component is still 1. Okay? Simple. That's it about your phase and component. Next, let's move into phase diagram. What is actually phase diagram? Phase diagram is a plot of pressure versus temperature. So you have your pressure versus temperature, okay? Which will show the condition of a substance exists in solid, liquid or gas. And generally, your phase diagram looks something like this, where you can see you have your pressure against your temperature, okay? And your pressure most of the time will be in atm, while your temperature can be in Kelvin, can be in degrees Celsius. In this video, I'm going to stick with degrees Celsius. It can be in Kelvin, depends on the question, okay? So a basic of phase diagram is you have an area of solid. This is the area of solid, and make sure solid is always sitting on the left, okay? Next, we have an area of your liquid, and your area of your liquid is always on the right, upper right. While last but not least, you have the area of your gas. So this is the area of your gas, and you can see that you are having a gas over here. Okay? So phase diagram is definitely talking about phases. So the phases that we talk about is your solid, liquid, and gas. Make sure you know the position of each and every one of them. Where should your solid located, where is your liquid located, and where is your gas located. Okay? And what is the function of phase diagram? The function of phase diagram is actually used to identify the substance is now in solid, liquid, or gas at a very specific pressure and temperature. So let's say this is my phase diagram of my compound or a substance unknown X. And by using the phase diagram of this compound, we can identify the substance exists in what phase at a certain pressure and temperature. For example, if my pressure that I'm talking about is over here 10 atm, let's say, okay? And then the temperature over here, let's say 50 degrees Celsius. So we can extrapolate the curve, and then you realize that at 10 atm and also 50 degrees Celsius, your compound exists in liquid. Can you see that? So that is the use of phase diagram, okay? Every single compound, every single substance will have their own phase diagram. Because by using the phase diagram of that particular compound, we can know the phases that exist by the compound or the substance at a certain pressure and temperature. Okay? Simple. So, that is the basic thing that you need to know about phase diagram. There are a few more basic things that you need to know about a phase diagram. For example, the first one, line AO. What is mean by line AO? That is my A, that is my O. So this is the line AO. The line AO is your sublimation and deposition line. What is mean by sublimation and deposition? We know that sublimation means your solid become gas straight away. Deposition means is your gas become solid straight away. Agree? So, you can see over here why we name the line AO as your sublimation or deposition line. Because between the AO, the phase that we have is your solid and also your gas. So, this line is the changing between the solid and gas. That's why your line AO is your sublimation or deposition line. Okay? And on that particular line, alright, on the line is the temperature and pressure where the solid and gas exists in equilibrium. Means if I'm having a dot over here on that particular line, this pressure and this temperature is where your solid and gas exists in equilibrium. Same goes to here. Alright, on top of the line means that you are having your solid and gas is in equilibrium for this line AO. Okay? Next that we have is your line OB. Look at it. So your line OB is here. That is my line OB. Having your O over here and having your B over here. And your line OB is between your solid and your liquid. That's why the name of the line is your melting and freezing line. It's the changes between the solid to liquid or the liquid to solid. That's why the name of the line is actually the name of the physical changes. Okay? And as always, on that particular line, when you have a dot on that particular line, it means at that particular temperature and pressure, the solid and liquid exist in equilibrium. So on the line AB, your solid and liquid exist in equilibrium. Okay? Simple? Easy. From the trend, you already know that the next line that we are going to explain is your line OC. Okay? And you can see from here, your line OC is between your liquid and also your gas. Okay? So, the name of the line OC will be vaporization and condensation. The changing from your gas to your liquid and your liquid to your gas. Okay? That is your vaporization and condensation. Knowing that the vaporization is from your liquid to gas and your condensation is your gas to liquid. Okay? Simple. And obviously the same thing. What will be in equilibrium for this line? At this temperature and pressure on that particular line, the liquid and gas is in equilibrium because your line OC over here is between your liquid and your gas. So on the line OC, alright, at any point in that line OC is the equilibrium between your liquid and gas. Simple? Easy. Next thing that we are going to look at is 2 points. The first one is your point O. The point O over here is what we call triple point. This is your triple point. So what is actually mean by triple point? Triple point is a point where at that particular temperature and pressure, the solid, liquid and the gas of your substance exist in equilibrium. So on this point, that what we call triple point, you can see that you have your liquid, you have your solid, you have your gas. So on here, you have your solid, liquid and gas exist in equilibrium. Okay? Simple. Next, and also the last point that we are going to talk about is your point C. Can you look at your point C over here? Your point C is what we call critical point. Point C is your this one. That is your point C. Okay? So your point C is your critical point. What is mean by critical point? This is the last point where we can differentiate liquid and gas. When you have the temperature and pressure above of this point, we cannot distinguish liquid and gas. Okay? So critical point is the maximum temperature and pressure that you can have to distinguish, to differentiate liquid and gas. If you have a pressure and temperature above of this point, we cannot differentiate liquid and gas. Okay? That's why on here, we cannot differentiate who is your liquid, who is your gas. That is what critical point stand for. Okay? The maximum temperature and pressure for us to distinguish liquid and gas. Anything above the critical point, we are unable to distinguish the liquid and gas. See that? Simple. So that is all the basic thing or the general thing about a phase diagram that you need to know. Let's go into detail. We are going to discuss two phase diagrams. We are going to discuss phase diagram of carbon dioxide and also phase diagram for water. Okay? Let's start off with the phase diagram of carbon dioxide. First and foremost, how to draw the phase diagram, starting off with your axis Y, which is pressure, and let's say my pressure is in atm. And then the x-axis is your temperature, and let's say my temperature right now is in degree Celsius. So, your phase diagram for carbon dioxide, the way of drawing should be as simple as one line, two line, and then a positive straight line. Okay? So, label the phase. That is my solid. That is my liquid. That is my gas. See that? Alright? That is the way that we draw the phase diagram of your carbon dioxide. And of course, label the point. You can label it with any alphabet that you like. Let's say I label it as my X. So you can label over here your point X. is your triple point. Okay, you can just put down the label. And then over here, your critical point, make sure your critical point is between liquid and gas. So liquid and gas, that is my critical point. Let's say that is my point Y. So you just label that is my point Y. And my point Y is my critical point. Last but not least, when you draw a basic phase diagram, the things that you need to have is your axis labeled with the unit. The phases must be putting down. Well, the entire video is talking about phase diagram. So phase is definitely the first thing that you put down. Okay? The third thing is your triple point and your critical point. Make sure you label where is your triple point, where is your critical point. And last but not least is the position of your atmospheric pressure. Knowing that your atmospheric pressure is 1 atm over here. So where should your 1 atm located? Bear that in mind for your CO2, your atmospheric pressure 1 atm must be sitting below your triple point. So that is your triple point. Your 1 atm must be sitting anywhere but must be lower than your triple point. So that is my 1 atm. Okay? It doesn't matter where is the 1 atm, but it does matter that your 1 atm must be lower than this triple point. Okay? So for CO2, your 1 atm must be lower than your triple point. This is a basic drawing of the phase diagram of your CO2. Okay? Simple. And this is the detailed drawing of my phase diagram of CO2, but the basic thing is still that your pressure 1 atm, temperature in degrees Celsius, the presence of your solid, the presence of your liquid, and the presence of your gas. Can you see that? And then the position of your triple point, the position of your critical point. Alright? And last but not least, the position of your 1 atm atmospheric pressure. And as we all agree just now, for the carbon dioxide, your 1 atm must be sitting lower than your triple point. Can you see that? Okay? So there are a few things that we are going to discuss for a phase diagram of carbon dioxide. The first one is definitely all the name of the line, but you realize that they are actually quite similar. The first one is your line A and your O. So this line is between your solid and your gas. Therefore, it's a sublimation and deposition, because we know that is the changes between solid to gas or gas to solid. Okay? Next is your line OB. So over here you have your O and also your B. So your line OB over here is between your solid and liquid. That's why the name is your melting and freezing. So that is between your solid and your liquid. Okay? Simple. Next and last but not least is your line OC. So you can see over here that is your O, that is your C. So this line of OC is between your liquid and gas. Therefore, the name will be vaporization or condensation slope. Okay? Vaporization or condensation slope means it's the interchange between liquid to gas or gas to liquid, vice versa. Okay? And then, in every phase diagram, there is 3 lines that you need to know the name and 2 points. Definitely, the first one is your triple point. So your triple point is your point O over here. That is your triple point. Okay? Where your solid, liquid, and gas exist in equilibrium. Last but not least, definitely your critical point. So critical point is sitting between your liquid and your gas, where that is the maximum temperature and pressure that we can differentiate liquid and gas. Any temperature or pressure above your critical point, we cannot distinguish liquid and gas. So that is your point C, critical point. That is the 5 basic things that you need to know about a phase diagram of carbon dioxide. So let's explain in more detail about your point C, critical point. So that is my point C, critical point. Point C, I mean, is this one. So from here, we know that the critical point of carbon dioxide is 73 atm and also 31 degrees Celsius. That is our critical point for carbon dioxide. So that is the temperature and pressure above which is impossible to liquefy a gas. So anything above this critical point, we are impossible to liquefy a gas anymore because we cannot even differentiate which one is your gas, which one is your liquid. The same thing over here, when you have a great pressure applied, liquid and gas phases is indistinguishable. So anything that you have higher than 73 atm over here, we cannot differentiate liquid and gas. So your critical point is the maximum temperature and pressure that you can differentiate your liquid and gas. Anything above critical point, we cannot differentiate liquid and gas. Okay? The next point that we are going to look at is your point O. Your point O, as we all know over here, your point O is your triple point. So the point O for your carbon dioxide is right now at 5.2 atm and also negative 56.6 degree Celsius. That is the position of your triple point for your carbon dioxide. Okay? And as we all agree just now, the triple point for your carbon dioxide over here must be higher than your 1 atm. That is your 1 atm. Okay? Make sure the triple point of your carbon dioxide must be higher than your 1 atm. Why it must be higher? Why I keep repeating that your triple point of your carbon dioxide must be higher than 1 atm? Because at 1 atm at our atmospheric pressure, liquid carbon dioxide does not exist. Have you ever come across liquid carbon dioxide in your life? No, because at our surrounding 1 atm, liquid carbon dioxide doesn't exist. So at 1 atm, as you can see, we will only cross the solid and also the gas. Because in 1 atm, carbon dioxide only exists in your solid and your gas. And the solid that we are talking about is your dry ice. And the gas that we are talking about is the carbon dioxide gas that we have in our surrounding. Okay? So your 1 atm for carbon dioxide can only pass through your solid and your gas. Okay? That is your 1 atm. That's why your triple point over here must be higher than your 1 atm, because anything above triple point, you need to pass through solid, liquid and gas. But we know that your carbon dioxide at 1 atm, liquid does not exist. That's why triple point of your CO2 must be higher than 1 atm. Okay? Your carbon dioxide only exists in solid and gas. Therefore, your carbon dioxide at 1 atm can only sublime or deposited. Okay? We can only change from the solid straight away to the gas, or from the gas straight away to solid. Okay? Bear that in mind, we never come across carbon dioxide liquid in our daily life. You only have your dry ice, your carbon dioxide in solid, or your carbon dioxide gas where your CO2 in gas. Okay? So that is the reason why your triple point must be higher than 1 atm in your phase diagram of carbon dioxide. Okay? And the next thing that we are going to discuss is quite important. Alright, it's one of the main things in this entire video, is your line OB. For the phase diagram of your CO2 and water, we need to compare this line OB. Looking at the line OB over here is the line between solid and liquid. Because we can name it as a different name. You can name XY, you can name AB, you can name PQ, it doesn't matter. But the line that we want to look at is the melting and freezing line, which means it's the line between your solid and your liquid. And this line or this slope over here must be a positive slope in your carbon dioxide. Your line OB must be positive slope. Alright, it must be positive, which means it's increasing. And it's increasing lean on the right. Positive slope means your line will be lean on the right. Okay, that is a positive slope, moving towards the right. Okay, and why your line OB must be positive? Because your solid carbon dioxide is more dense than the liquid carbon dioxide. 1. Okay, and the second information that you can get from this line is your melting point of your solid CO2 will increase when the pressure increase. Let's see. So this is my lower pressure over here. When the pressure is very low, you can see that is my temperature. My temperature is also very low. But what happens if my pressure is higher? When my pressure is higher, you realize that your melting point of your carbon dioxide also increase. Can you see that? This one is the melting point for low pressure. This one is the melting point for high pressure. So your melting point of your solid CO2 will increase when the pressure increase. And that is the two things that you can get from the line OB when it is positive slope. Bear that in mind, the line OB is the line between your solid and your liquid. Okay? So for the phase diagram of CO2, your line OB or your line solid liquid must be positive, which means it must be leaning on the right. Okay? That is my positive slope. Okay? Simple. And from the positive slope, we know that the solid CO2 is more dense than the liquid CO2, and the melting point of solid CO2 will increase when the pressure increase. That are the two information that you will have from the line OB when it is positive. Okay? Remember this. Alright? And the last thing about the phase diagram of CO2 is the anomalous behavior. And the anomalous behavior in the phase diagram of CO2 over here is your triple point must be above 1 atm. We have discussed that because at 1 atm, CO2 cannot be in liquid state. So you can see over here, that is your triple point, that is your 1 atm. So your triple point must be higher than your 1 atm. Therefore, at 1 atm, your CO2 can only have solid and gas. So your 1 atm, you only have your solid and your gas over here. Okay? As a result, your carbon dioxide does not melt at 1 atm, but at 1 atm, your carbon dioxide will subline and form gas. Subline and form gas means it's the changing from the solid to your gas. Alright? And as I told you just now, the solid that we are talking about is the dry ice, which is your solid carbon dioxide, and the gas is the normal carbon dioxide gas that we have in our surrounding. This is the anomalous behavior for the phase diagram of your carbon dioxide. Why the triple point must be above 1 atm. Okay? Simple. That is your final answer basically. Next, let's go for the phase diagram of your H2O. Okay? We have talked about everything about carbon dioxide just now, and I hope you understand the phase diagram of carbon dioxide. Now, we are moving to the phase diagram of H2O. So, as always, your y-axis will be your pressure, and the pressure will be still in atm, easier for me. And then your x-axis will be your temperature, and since we are using degree Celsius, so I will stick with degree Celsius. And how do we draw the phase diagram of water? The two lines at the beginning will be the same, but the last line will be slightly different. The slope over here shall be negative. Alright, the slope over here must be negative. Bear that in mind. So next, label the phase. That is my solid. That is my liquid as always. That is my gas. So your solid, liquid and gas position will not change. Alright? And after you have labeled the pressure, temperature, after you have drawn the shape of your phase diagram and label their physical phase, next, what do we need to do? Label the 2 points. So that is my point X and that is my point Y. You can label any name that you want, to be honest. Make sure you label them. And we know that your point X over that, same like your carbon dioxide, that is your triple point, where your solid, liquid all exist at that particular pressure and temperature. And then you have your point Y over that, and your point Y is your critical point. Remember that? And make sure your critical point is between your liquid and your gas. And we are not done yet. Bear that in mind, we need to label the position of 1 atm. And there are two big differences between the phase diagram of carbon dioxide and water. The first one is the position of 1 atm. Just now in carbon dioxide, your 1 atm must be sitting lower than the triple point. Because in carbon dioxide, triple point must be higher. Vice versa. 1 atm over here must be higher than your triple point. So you can see that is my position of your triple point. Okay, so that is my triple point for your water. And in water, your 1 atm must be higher than your triple point. Okay, so why 1 atm must be higher than your triple point when we are talking about water? Very, very simple. At 1 atm is our surrounding right now. So, do we have solid, liquid and gas of a water? Yes. Alright? Because at 1 atm, it will pass through all the three phases. So, you have your solid, you have your liquid, you have your gas. So, at 1 atm, your H2O can be in ice, which is a solid. You can have a water, a normal water, which is your liquid. You can have vapor, alright? Your water vapor, which is your gas. So 1 atm, your water can exist in all three phases. Agree? Since at 1 atm, your water can exist in all three phases, that's why in your water phase diagram, your 1 atm must be higher than your triple point. Okay, makes sense? That is the first biggest difference between your water phase diagram and your carbon dioxide. The second big difference is your slope between your solid and liquid. The slope over here must be a negative slope. Okay, I will explain why the slope is negative later on. But the slope between the solid and liquid must be a negative slope. That is the two differences between the phase diagram of water and carbon dioxide. Make sure you know that, okay? So, as always, let's go through the basic thing of a phase diagram in water. So, looking at the phase diagram of water, the first one is your line AO. So, the line AO, again, is between your solid and your gas. So, between the solid and your gas over here, which means is your sublimation and your deposition. Sublimation is between your solid to become gas. Deposition is your gas to become solid. That is your line AO. Next is your line OB. So between your O and your B over here, the line OB is sitting between your solid and your liquid. So it's the interchange between solid and liquid. Therefore, the process that the line can happen is melting and freezing. Melting is your solid to become liquid, where your freezing is your liquid become solid. Okay? Next and last but not least is your line OC over here. So talking about your OC is this one. That is my C. Okay? So your line OC obviously is between your liquid and your gas. So it's the interchange between liquid and your gas, where you have your vaporization and condensation process happen. Vaporization from your liquid to become gas, condensation from your gas to become liquid. So that is the process that can happen on every single line. Bear that in mind, you can name them differently. You are not necessarily using A, B, C, O. You can use W, X, Y, Z. The same, okay? Just make sure you label them correctly and also clearly. Okay, bear that in mind, you can use any unknown that you want. Okay? Next, the first point is your triple point. So you have your point O over here. You have the presence of your triple point. So the triple point means all the solid, liquid and gas exist at the same time in that particular pressure and temperature. That is what we call triple point. Last but not least is your critical point over here. That is your critical point. Okay? Bear that in mind, critical point is definitely between liquid and gas. Don't mix it up. Okay? Critical point is always between liquid and gas. Let's start with your point C. So your point C over here obviously is your critical point. So that is the critical point of your water. And the critical point of your water is 218 atm and also 374 degrees Celsius. The similar explanation for your carbon dioxide, what is actually critical point? Critical point is above this temperature and pressure, it's impossible to liquefy a gas. So anything above this temperature and pressure, we cannot liquefy the gas because I cannot even differentiate liquid and gas. So anything above this temperature and pressure, we cannot differentiate liquid and gas. The same thing like your carbon dioxide, anything above this point, alright, any temperature and pressure above this point, we cannot differentiate liquid and gas. Simple. That is about critical point. Same thing like your carbon dioxide. Whenever we are talking about critical point, it means the same meaning, but the temperature and pressure will be different. Okay? How about your triple point? So your triple point over here, that is my triple point for your water. Okay? So triple point over here for your water is 0.006 atm and also 0.01 degrees Celsius. That is the triple point of your water. And as I highlighted just now, your triple point over here in the water must be lower than the 1 atm. See that? Like I said, triple point must be lower than 1 atm. Why triple point must be lower than 1 atm? Because at 1 atm, your solid, liquid and gas water will exist but in a different temperature. You can have your solid, you can have your liquid, you can have your gas, but at different temperature. Okay? So I hope you really understand why the triple point of the water over here must be lower than the 1 atm. Okay? Because your water can exist in the solid, liquid and gas at our 1 atm atmospheric pressure. Your ice, your water and your vapor. Remember that? Okay? And this is the first differences between your water and your carbon dioxide phase diagram. The second differences is about your line OB. And like I said, we can label it with different name. It could be your line XY, it could be your PQ, it doesn't matter. But the line that I'm talking about, the slope that I'm talking about, is the slope between your solid and your liquid. That is the second differences in the phase diagram of your H2O. So the line OB is definitely between your solid and your liquid. Okay? Changing whether from the solid to liquid or vice versa. And in the water, your line OB must be a negative slope. Okay? What is meant by negative? Can you see that your slope right now is lean towards the left? So when the graph is lean towards the left over here, guys, that is what we call negative slope. Alright? So bear that in mind, negative means that the value decrease. So it's lean towards the left, it leans towards the zero. That is a negative slope. And why the slope is negative? Because your solid H2O is less dense than your liquid H2O. Remember that when you have a cup of water, that is your H2O, your ice will be floating on top of water. Remember that? Why your ice will be floating on the water? Because your solid H2O is less dense than the liquid H2O. That's why the slope between the solid and liquid will be negative. Because your solid is less dense. Okay? And from that line also, we can see that the melting point of the solid H2O will decrease when the pressure increase. So when the pressure increase, that is my high pressure, okay, you can see that your melting point is actually only here. So that is the melting point when the pressure increase. But if my pressure is very low over here, let's say, so if that is my low pressure, you can see that my melting point for the low pressure is higher. Can you see that? So in solid water, the melting point will be inversely proportional with the pressure. The higher the pressure, the lower the melting point. So this is the two things that we can know from the negative slope between your solid and your liquid. Okay? So bear that in mind, this is the second differences between your carbon dioxide phase diagram and your water phase diagram. And the last but not least for the phase diagram of water is definitely the anomalous behavior. And the anomalous behavior in the phase diagram of water is your negative slope between your solid and liquid. So between your solid and liquid, there is a negative slope. Why? Because your solid water floats on a liquid water. And the explanation for this is like the one that you learned in your topic 4. Why your ice is less dense than your water. Because in ice, every water molecule is tetrahedrally bonded by another 4 water molecules. And this will cause the ice to have an open structure that have a lot of empty spaces. That's why your solid water, the ice, will float on the liquid water. Okay? This is the anomalous behavior that you can discuss in the phase diagram of water. Why the slope between the solid and liquid in the water is negative. Okay? So, simple. This is the phase diagram of my carbon dioxide, and this is my phase diagram for water. And bear that in mind, there are 2 differences that you need to pay attention. First one is the position of your 1 ATM and also the triple point. So that is the triple point of carbon dioxide and 1 ATM of the carbon dioxide. And we agree that in your carbon dioxide, your triple point must be higher than your 1 ATM. While for the water, that is my 1 ATM, that is my triple point. And in water, we know that your 1 ATM must be higher than the triple point. Okay? So that is the first differences. The second difference is the slope between your solid and your liquid. Looking at the slope between your solid and liquid, and in this case, is your line OB. Can you see that your line OB? In the carbon dioxide, the line must be a positive slope. While for your water over here, your line OB is between the solid and liquid. This one must be a negative slope. Okay? So these are the 2 main differences between the phase diagram of carbon dioxide and the phase diagram of water. The position of your 1 ATM and triple point, and also the slope between the solid and liquid. Okay? Make sure you can draw the phase diagram and make sure you understand why we have these 2 differences between the phase diagram of carbon dioxide and the phase diagram of water. Okay? Make sure you know how to explain. And that's it about phase diagram for carbon dioxide and water. Next, we will be going into the changes of phase. We have 2 conditions for the changes of phase. The first one is isobaric. Isobaric means at constant pressure. Second is your isothermal. From the word thermal, you know that is at a constant temperature. Okay? So, let's look at isobaric first. What do I mean by constant pressure? Looking at your phase diagram, your y-axis is your pressure. Constant pressure means we are going to talk about one pressure only. The temperature can change, but the pressure must remain constant. That is your isobaric constant pressure. Next is your isothermal. From the word thermal, we know that is a constant temperature. And the axis that we will look at is your temperature on the x-axis. And you can see this is my constant temperature, and the temperature must remain the same. And in here, your pressure can change, but your temperature must remain the same. That is your isobaric and isothermal. Okay? So, how do I answer the question for isobaric constant pressure? Describe the changes from point E to point F. So, that is my point E over here. That is my point F. So, the first thing that we are going to do is draw a straight line from your point E to your point F. Okay? Next, what are we going to do is, we need to put down more dots for ourselves. So, where should we put the dot? We know that that is my solid, that is my liquid, that is my gas. So, the extra dot that you put in must be on the line intercept, and also on that different phase. So, we have 3 extra lines over here. What should I label the line with? You can label with any unknown that you want, but make sure it's not repeated. So, for example, you already have your A, B, C, D. Don't use A, B, C, D. Okay? So, let's say I have my P QR. So label the dot, alright, label the point, and label the point. So what are we going to do is to describe the changes from every single point that we have. So we have 5 points over here, and therefore, in your answer, we are going to have 5 explanations. Okay, let's see. How do we explain? Starting off with your point E. Just as simple as substance is in solid phase. Alright? Simple. That is my point E, and my point E is in solid. That's it. If you know what is the substance, then we are going to use the name of the substance. If we don't know the name of the substance, then just use the unknown. Okay? Next, moving to your point P. So for the point P, how do we write? Because it's on the line. Remember the equilibrium? So this is the line between your solid and liquid. Just mentioned, point P means solid and liquid exist in equilibrium. That's it. Simple. Okay? Next, moving to your point Q over here. So your point Q is located in the liquid. So label point Q. So what do we write and how do we write? Just write substance is in liquid state. Simple. Okay? Moving to the next point, you have your point R. So your point R over here is between your liquid and your gas. This is the point where you are sitting in between liquid and gas. So just say in the point R, substance in liquid and gas exists in equilibrium. That's it. Alright, and last but not least, your point F. And you can see over here, your point F is located in the gas area. So just simply write substance is in gas phase. And you are done. That is how we describe the changes from point E to point F. So make sure from the point E to point F, you draw a straight line and then you add in your own extra point that you want to discuss. Okay? Simple. Next, and also last but not least, isothermal. Isothermal means constant temperature. And we are going to talk about the changes from the point I to point J. So find your point I. That is my I. That is my J. So draw a straight line on the point I to J. Okay, that is my straight line. And how many extra points I need to put down? That is my solid. That is my liquid. And I already have a point in liquid. So we are good. That is my gas. And we already have a point in gas. So do I need to put 3 points like the question in isobaric just now? No, because you only need 1 more. Alright, you only need 1 more. The I to J is the crossing between gas to liquid. Agree? And it only passed through 1 equilibrium. So just label this 1 extra point, X. So can you see over there? Your explanation will only involve these 3 points. And you're almost done there. So starting off with your point I. Since we don't know what substance is that, so we just simply label substance. Okay? If you know what compound you are discussing, or if the question tells you what is the substance, then you are going to write the name of the substance. Okay? So point I is the substance exists in gas state. Alright? Moving to your point X, the point that we add in by ourselves. So in the point X, substance exists in gas and liquid in equilibrium. Bear that in mind whenever it's on the line, which means the 2 faces, okay, between the line is in equilibrium. Alright? Last but not least, your point J. So your point J means liquid. Your J is located in liquid. Therefore, substance exists in liquid phase. And you are done. And that is how we describe the changes in isobaric or isothermal, depends on the question. Simple, easy, okay? And that's it about the entire subtopic 5.4 phase diagram. If you have any question regarding anything in this subtopic, drop it in the comment below and I'll get back to you as soon as I can. I really hope that you'll understand phase diagram after watching this video. So make sure you like the video, subscribe to my channel, and I'll see you again in the next video.
TunePocket.com